14, Stoichiometry and Gravimetric Analysis. You are working for a company that makes water softening agents for homes with hard water. Recently, there was a mix-up on the factory floor, and sodium carbonate was mistakenly mixed in a vat with an unknown quantity of distilled water. You must determine the amount of sodium carbonate in the vat in order to predict the percentage yield of the water softening product. When chemists are faced with problems that require them to determine the quantity of a substance by mass, they often use a technique called gravimetric analysis. In this technique, a small sample of the material undergoes a reaction with an excess of another reactant. The chosen reaction is one that almost always provides a near 100% yield. If the mass of the product is carefully measured, you can use stoichiometry calculations to determine how much of a reactant of unknown amount was involved in the reaction. Then, by comparing the size of the analysis sample with the size of the original material, you can determine exactly how much of the substance is present. This procedure involves a double displacement reaction between strontium chloride and sodium carbonate. In general, this reaction can be used to determine the amount of any carbonate compound in a solution. You will react an unknown amount of sodium carbonate with an excess of strontium chloride. After purifying the product, you will determine the following. How much product is present? How much sodium carbonate must have been present to produce that much product? How much sodium carbonate is contained in the 575 liters of solution? Materials. You will need the following items to complete this lab. Balance, beaker tongs, 3 250 milliliter beakers, distilled water, drying oven, filter paper, glass funnel, glass stirring rod, graduated cylinder 100 milliliters, ring and ring stand, rubber policeman, wash bottle, spatula, sodium carbonate solution 15 milliliters, 0.3 molar strontium chloride solution 15 milliliters. Let's head to our lab. Let's begin our data collection by setting up a data table. We will need to know the volume of sodium carbonate solution added, the volume of strontium chloride solution added, the mass of dry filter paper, the mass of a beaker and a paper towel, the mass of a beaker, paper towel, filter paper, and precipitate, and that should allow us to find the mass of the precipitate. For our procedure, we will begin by washing glassware and rinsing it with distilled water. Next, we will measure and record the mass of a piece of filter paper to the nearest 0.01 gram. Then we will set up our gravity filtration apparatus. We will label a paper towel and place it in a clean, dry 250 milliliter beaker. will measure and record the mass of the beaker and paper towel to the nearest 0.01 gram. Next, we will measure about 15 milliliters of sodium carbonate into the graduated cylinder and record to the nearest 0.5 milliliter. We'll pour the sodium carbonate into a clean, dry 250 milliliter beaker. Let's clean our graduated cylinder and rinse it with distilled water. Next, we'll measure about 25 milliliters of strontium chloride into the graduated cylinder and record that to the nearest 0.5 milliliter. We will pour the strontium chloride into the beaker containing the sodium carbonate and gently stir it with a stirring rod. Next, we'll measure another 10 milliliters of strontium chloride into the graduated cylinder and record it to the nearest 0.5 milliliter. We'll slowly pour this into the beaker and stir, and then repeat the process until no more precipitate forms. We'll allow the precipitate to settle, and then slowly pour the contents of the beaker through the funnel. Using a rubber policeman will transfer as much precipitate as possible. Using the wash bottle, we're going to rinse the rubber policeman and beaker and the stirring rod Pour the contents through the funnel and repeat it several times. Use as little distilled water as possible. Carefully rinse the precipitate and filter paper with a small amount of distilled water. Carefully remove the filter paper from the funnel and place it in your labeled paper towel. Place the filter paper and paper towel in a clean, dry beaker. Place the beaker in a drying oven overnight. For our purposes, we will use a normal household oven and leave the light on. We'll be sure that the door stays closed, no heat, just light. Record the mass of the beaker, paper towel, filter paper, and precipitate. Balance your formula. Our molar ratio is 1, 1, 2, 1, and 2. Our precipitate is strontium carbonate, and the mass of the dry precipitate is found by subtracting the mass of the beaker and paper towel from our final dried product. Our product was 1.65 grams of precipitate. Now, if we want to know how many moles of sodium carbonate are in our 15 milliliter sample, we simply take our moles of strontium carbonate and multiply it by the molar ratio. In this case, our molar ratio was 1 mole of sodium carbonate to 1 mole of strontium carbonate. So our answer becomes 0.11 mole of sodium carbonate. Now, if we take that 0.11 mole of sodium carbonate and multiply it by the conversion factor for molar mass of sodium carbonate, we can find out how many grams of sodium carbonate were in that 15 milliliter sample. Now, if we take our 0.11 moles of sodium carbonate per 15 milliliter sample and multiply it by the conversion factor for milliliters to liters, we find that we had 7.33 moles of sodium carbonate per liter. And if we multiply that by the volume of our vat, which was 575 liters, we'll find that we have 4,216.67 moles in our 575 liter vat. We could take our 4,216.67 moles of sodium carbonate in our 575 liter vat and multiply that times the molar mass conversion factor for sodium carbonate and find that we have 44,692.80 grams of sodium carbonate in our 575 liter vat, which is 44.69 kilograms of sodium carbonate. And for us Americans, that's about 98.5 pounds of sodium carbonate in a 151.99 gallon vat. Here's the report from our supervisor. What was your limiting agent? Well, we chose to use sodium carbonate as the limiting reactant. Could you have used either sodium carbonate or strontium chloride as a limiting agent? No, we couldn't. So, in explaining to her why, in order to determine the amount of sodium carbonate present in the solution before the reaction, sodium carbonate has to be the limiting reactant. What soluble impurities were a concern, and how did you confirm that they did not impact your results? Well, we know that one of the products of this reaction is sodium chloride, which is table salt, and that is soluble in water. So, sodium chloride was a potential soluble impurity, thus the precipitate was rinsed before drying. How many grams of sodium carbonate were present in our 575 liter vat? Well, we know that someone added 44,692.80 grams of sodium carbonate to the 575 liter vat. Congrats on a job well done.